This video is about magnification and resolution. So by the end of this video, you should be able to define both magnification and resolution. You should also be able to calculate the magnification of a microscope, and along with that, calculate the actual size of an object in the image. And these two calculations both come from the same equation. Magnification is how much larger an object appears under a microscope. So you've looked down microscopes, you've seen that things that we can't see with our eyes are visible. The magnification tells us how much bigger they actually appear. So if an object is 10 times bigger, then the magnification is 10 times. If an object is 400 times bigger, then the magnification is 400. So it's just a number with a times at the end of it. How much bigger is something? And you can see in the image that something that's 25 times bigger, we really can't see the cells that are going on. If we make it 100 times bigger, we can see the cells, the image is magnified, but by the time we make it 1,000 times bigger, that's when we can actually see what's happening inside the cells. So magnification is just making things look bigger. Resolution, on the other hand, tells us the size of the smallest object in the image. So on the right-hand side, we have a low resolution, and you can see it looks a bit blurry. On the right-hand side, we have high resolution, and you can see we've got a lot of details in there. The smallest object we can see is pretty small. Now, you have to calculate magnification. If we're talking about a microscope, calculating magnification is really easy. It's just the number on the objective lens times the number on the eyepiece lens. Now, the microscopes we use have an eyepiece that is 10 times. That means the eyepiece alone will make something look 10 times bigger. So if you use the 4 times objective lens on the microscope, so look for the little 4 on the microscope, then the magnification you get overall is your objective lens times your eyepiece, which is 40 times overall. The microscopes we've got have got a 4 times objective, a 10 times objective, and a 40 times objective. So we can make things look 40 times bigger, 100 times bigger, or 400 times bigger. If you don't have a microscope, if you're looking at an image or a photo or something, then we need to use this triangle. You should remember the triangle from our density calculations, and we use this one in exactly the same way. So magnification over here is equal to the height that you measure in the image. So in the photo, how tall is it? Get your ruler out, actually measure it. How big is it? Versus the actual height or the actual size of the object in real life. So 3 things, just like before, whatever you're calculating, cover it up. So get your thumb out. If we're calculating the image height, put your thumb over the image height and you'll see that it's magnification times object height. If we're calculating magnification, then it is image height, so however big you measure it in the image or the photo, divided by however big it is in real life. To summarize, if you know the height of something in a picture, so if you've got a picture and you know how big it is in the picture, that number goes on top and you always divide. And let's just undo that and get the right colors there for the color scheme people. So if you know the height of something in a picture, if you can measure it in a picture with a ruler, that goes on top and you're doing a divide. If you don't know the height of something in the image, so if you don't know what it looks like in the picture, multiply the other 2 numbers together. Let's do some calculations. So we've got a light microscope with an eyepiece magnification of 20 and an objective lens of 50. So our magnification, because it's a microscope, we just multiply those 2 numbers together. 20 times 50 is just 1,000. So the magnification of our microscope is 1,000. In example number 2, we've got a photo of a 0.1 meter long lolly. So that's the actual size of the lolly. That's what its size is in real life. But in the photo, we measure it to be 0.5 meters long. We've got the image height in the photo. That means we divide. So our magnification is going to be the height in the image divided by the height in real life. And that gives us a magnification of times 5. So can you define magnification and resolution? Can you calculate the magnification of a microscope? And can you calculate the actual size of an object in an image?